Hello, hi everyone. Welcome to the Student the Brand. This is Vasua sir. Today topic is light reflection and refraction. Light reflection and refraction. Okay. Mm, 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 Hi everyone, welcome to the class. So this is Vasua sir. Today topic is light reflection and refraction topic. In this topic, we are going to discuss about reflection of light. Reflection of light. So I'm good. So how are you, ma? Okay. So do like, share, and subscribe to Student Brand and share to your friends. Ask them to join to the class. So share to everyone because live classes are going on, right? Yes. So yes, in this today live class, in this class, we are going to discuss about reflection of light, in angle of incidence, angle of reflection, laws of reflection, regular reflection, irregular reflection. After that, object and image, nature of the image formed by the plane mirror. Okay, nature of the image formed by the plane mirror. After that, we will discuss about object and image. Anyway, nature of the image formed by the plane mirror. Next one, spherical mirrors, concave mirror, convex mirror, concave mirror and convex mirror. After that, we will discuss about terms related to spherical mirror, ray rules and image formations, sign conventions, mirror formula, magnification, refraction. After that, critical angle, total internal reflection. After that, refraction through glass slab. So lateral shift, vertical shift, and lenses. So ray rules of lenses and image formation by lenses. After that, power of power of lens. All these points we'll discuss. Okay, so let's start. Let's get into the start. Let's get into the topic. Let's get into the topic. So I'm taking the plane mirror. So today topic is light reflection and diffraction. Light reflection, light reflection and refraction. Light reflection and refraction. Okay. So light reflection and refraction. So now, so I'm taking the plane mirror. This is a plane mirror. This is a plane mirror. This is a plane mirror. Okay. So incident ray, reflected ray, incident ray, reflected ray. The light ray which is perpendicular to the plane surface is called normal line. Actually, it is not there. So it is not existed. For our understanding, for better understanding of reflection of light, we are drawing the dotted lines. Okay. So incident ray, reflected ray, normal line lies on the same plane. You can see incident ray, reflected ray, normal line lies on the same plane. Okay, incident ray, reflected ray, normal line lies on the same plane. So you can see incident ray, reflected ray, incident ray, reflected ray, reflected ray, and the light ray which is perpendicular to the plane surface is called normal line. The light ray which is perpendicular to the plane surface is called normal line. The angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. and the lighter which is deviating, undeviated line, the lighter which is undeviating. Okay, so angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. Once again, so incident ray, reflected ray, normal line, incident ray, reflected ray. So incident ray, reflected ray, normal line. Okay, so the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, or reflecting back of the light from the reflecting surface is called reflection of light. Reflection of light. The angle between incident ray, normal line is called angle of incidence. Angle between reflected ray, normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. Okay, angle of deviation. So these are the points. These are the points. So now you can see here. Now you can observe. So angle between incident and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. Now you can observe here. Now you can observe. Okay. So loss of reflection. Loss of reflection. Loss of reflection. Incident ray, reflected ray, normal line lies on the same plane. Okay, incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. So you can see the first one is incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. So point number 2, angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay. So from this we can observe. So this is a linear angle. Linear angle is 180 degrees. Linear angle is 180 degrees. So that is angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Once again, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees. Understood? Understood? I hope it is very clear. From loss of reflection, angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. So that I can write angle of incidence. So you can see here. Okay. So angle of incidence plus angle of deviation equal to 180 degrees. Okay. Angle of incidence plus angle of deviation equal to 180 degrees. I hope it is very clear. Right. So now from this equation we can write angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence, and also we can write angle of deviation equal to 180 minus 2 angle of reflection. So how can you write like that? How can you write like this? From loss of reflection, angle of incident is equal to angle of reflection. So instead of angle of reflection, I wrote angle of incidence, so that I got, so angle of deviation equal to 180 minus 2 angle of incidence. So in the same condition, so instead of angle of incidence, if I write angle of reflection, so I'll be getting angle of deviation equal to 180 minus 2 angle of reflection. I hope it is very clear. Right? So angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of incidence. So these two formulas are very, very important. These two formulas very, very important. Okay, so the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light, the bouncing back of the light from the reflecting surface is called reflection of light. So the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. Okay, so here you can observe one thing. So see here, angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. The linear angle is 180 degrees. Linear angle is 180 degrees. Linear angle is how much? 180 degrees. So that is include of you can observe here, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So his circle, so total is 360 degrees. Half of the circle is 180 degrees. So here I am taking this angle is linear angle. So this I am taking 180 degrees, right? So that is include of angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees. Now you can observe here. So in the place of angle of reflection, if I substitute angle of incidence, then angle of deviation equal to 180 minus 2 angle of incidence. So in the place of angle of incidence, if I substitute angle of reflection, then I will get angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. Okay, so this is about angle of deviation equal to 180 minus 2 angle of incidence. So 180 minus 2 angle of incidence, and angle of deviation equal to 180 minus 2 into angle of reflection. 2 into angle of reflection. So that is about angle of deviation. That is about angle of deviation. I hope it is very clear. So this is about the bouncing back of the light from the reflecting surface is called reflection of light. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Okay, so this is about reflection of light. And loss of reflection, incident ray, reflected ray, normal line lies on the same plane, and angle of incident is equal to angle of reflection. Angle of reflection. I hope it is very clear. Angle between reflected ray and undeviated line. So the dotted line are initial direction of the incident ray. This is the initial direction of the incident ray. Angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. I hope it is very clear. Okay, just next one. So I hope your doubt is addressed. So that is angle of deviation explanation is completed. Next one, we will discuss about regular reflection and irregular reflection. Okay, regular reflection. Next, so you can see regular reflection and irregular reflection. Regular reflection and irregular reflection. Shall we discuss about it? Regular reflection and irregular reflection. Okay. Regular reflection and irregular reflection. So now you can see here. This is the plane mirror. This is a plane mirror. I am taking the plane mirror. Regular reflection. Regular reflection. So incident light rays are parallel to each other. Then reflected light rays are also parallel to each other. Incident light rays are parallel, then reflected light rays are also parallel to each other. This type of reflection is called regular reflection. Incident light rays are parallel, then reflected light rays are also parallel to each other. This type of reflection is called regular reflection. So I am taking this is the incident parallel beam, incident light rays. So after that, these light rays are reflected back. I hope it is very clear. Okay, incident parallel beam, reflected parallel beam, incident parallel beam, reflected parallel beam. So I hope it is very clear. Incident beam is parallel, reflected beam also parallel. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Coming to irregular reflection. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Example, plain mirror and still lake of water. Okay, so water at constant position. So that time the reflection of light will be regular reflection. Okay, coming to irregular reflection. So I am taking like this irregular reflection. Okay, so do like, share and subscribe to Student Brand. So if you like the content, if you like the explanation, go for super chat, super thanks, and go for membership to the channel. Okay. So please do like, share, and click on like button to reach maximum students. So here you can observe after reflection like this you can observe. So this is the regular reflection, and coming to this one is irregular reflection. Regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. Yes. Irregular reflection takes place. Irregular reflection is also known as diffused reflection. Irregular reflection is also known as diffused reflection. Okay, so diffused reflection takes place on wall, on cinema screen, on paper, on cardboard. Like that, many we can say irregular reflection or diffused reflection. Okay, so I hope it is very clear. Now we can see here. This is about regular reflection and irregular reflection. Now we'll discuss about object and image. Object and image. Object and image. The point of intersection of, here I will explain now few points. The point of intersection of reflector light rays is known as real image. The point of intersection of reflector light rays is known as real image. The point of intersection of extended incident light rays is known as virtual object. If you are extending the incident light rays, those extended incident light rays are meeting, that point is virtual object. If you are extending the reflector light rays, extended reflector light rays are meeting at one point, their image is forming, that is a virtual image. Because the light rays are coming from the object. If the light rays are coming from the object, so after reflection, the reflector light rays are extended, and those extended reflector light rays are meeting at one point, their virtual image is forming. Okay, so now you can observe here. Okay, so you can check. I'll be drawing this object and image, virtual object, real object, virtual image, real image, all those points I'll be explaining with the help of diagram. Just check once. So here I am taking the plane mirror. This is a plane mirror. Okay. So light rays are coming from the source. After reflection, those light rays are meeting at one point. Here, this is a real image. I already mentioned the point of intersection of reflector light rays. The point of intersection of reflector light rays is called real image. The point of intersection of reflector light rays is called real image. The point of intersection of extended incident light rays is known as virtual object. Okay, virtual object. So here you can observe. Here you can observe we are extending these light rays. Extended incident light rays are meeting, that is virtual object. Okay, so this is the I1 I2, this is the R1, R2. That is virtual object. And here I am drawing one more. So here you can observe like this. Here you can observe. So from this point light rays are coming. After reflection, those light rays are moving away from it. Those light rays are moving away from it. If you are extending these light rays, if you are extending these light rays, if you are extending these light rays, image is formed. That is, image is formed. What type of image it is? What type of image it is? Virtual image. What type of image it is? Virtual image. Virtual image. Right? Virtual. What is the virtual image definition? The point of intersection of extended reflector light rays is called virtual image. The point of intersection of extended reflector light rays is called virtual image. The point of intersection of reflector light rays is known as real image. So directly reflector light rays are meeting. If the directly reflector light rays are meeting, then that image is called real image. If you are extending the reflector light rays, extended reflector light rays are meeting at one point, there virtual image is forming. If you are extending either incident rays or reflector light rays, that is virtual. So if it is incident light rays, virtual object. If it is reflector light rays, virtual image. Okay, virtual image. Okay, so just check once here. So this is the real object and this one is the virtual image. Virtual image. I hope it is very clear. I hope it is very clear. Okay. So those who want notes, those who have any queries, okay. So if you have more doubts to discuss, so please you can contact to this number. I already given number. You can contact to me. So if you have more queries regarding the notes, regarding the classes, or anything, any information. So maybe there are you have so many questions to pose. So maybe I could not answer all those questions because due to topic explanation. So please try to understand and so please support me. So in this area, please support me in this area. Please understand. So I may not answer all of your questions. So if you need any notes, any classes, please so you can contact to this number. Definitely I will reach you out. So regarding anything, regarding classes, regarding notes, not only physics subject, remaining subjects, if you want notes, if you want classes also, so definitely I will respond to those questions. Just you can contact to that number. So let me know those who want questions regarding the classes, notes, and like if you have more type of questions, then definitely I'll answer. So in middle of the class, if randomly if I disturb, so it will be disturbed to the remaining students also, those who want to learn the subject, those who came for the subject in this time. So I appreciate all of you. Thank you so much for joining. Thank you so much for supporting. So please keep supporting me and do like, share and subscribe and share to your friends, share to as much as possible, share to everyone. Okay, so inform to everyone, those who are studying, inform to all of your friends, okay, and inform to everyone those who are studying from right from 6 to 12. So these concepts are very helpful for them. Inform to your near ones and so whomever it is, okay. Thank you so much for supporting. Keep supporting. So those who are new to the channel, please do like, share and subscribe to Student the Brand. Those who already subscribed, thank you so much. Just to go and watch remaining videos, those are there in my YouTube channel. Okay, so in this channel only, YouTube channel means, so in this channel only, just to go and check. Okay na? So please support my channel, inform to everyone, and if you want you can go for super chat and super thanks and membership also, those are available. Just you can go and check and click on that. Okay, thank you so much. If you want to support me regarding the channel, you can go and you can go for super chat, super thanks and membership, and you can be a member to the channel to get address your doubts, your queries. Okay, so be the first person to learn the subject from the channel, right? Yes, be a member to the channel, so then automatically you'll get more benefits from the channel definitely. And go for super thanks and super chat, right? Yes, come to the point now. So here incident ray I1, incident ray I2. After reflection, those light rays are meeting at one point. This is real image. The point of intersection of reflector light rays is called real image. The point of intersection of extended incident light rays. The point of intersection of extended incident light rays is called virtual object. Virtual object. Okay. So here you can see. So from this point, light rays are coming. After reflection, those light rays are moving away from the principal axis. So we are extending this reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. That is a virtual image. Yes or no? That is a virtual image. I hope it is very clear. Real object. So I will draw one tabular column. Then you will get to know. So just check this tabular column. So object is real. Object is real. Image is virtual. Object is real. Image is virtual. Object is virtual. Image is real. Okay. Once again. Object is real. Image is virtual. Right? Virtual. Image is virtual. Image is virtual. Right? Here is virtual. Object is real. Image is virtual. Object is virtual. Image is real. Image is real. So here you can observe this diagram. Object is virtual. Image is real. Object is virtual. Image is real. In this case, real object. Image is virtual. That's enough. Okay. So keep in mind this point. These points are very, very important. So definitely you'll get it. So next topic related to this one only. So nature of the image formed by the plane mirror. Now we will discuss those points, right? Let's start. Nature of the image formed by the plane mirror. Nature of the image. Let's start. Nature of the image formed by the plane mirror. Okay. So here I am taking the object. So when light ray is passing along the normal line, if the light ray is passing along the normal line, it retraces its original path. It reflects back into the same path. Understood? If the light ray is passing along the normal line, it retraces its original path and reflect in the same direction. Reflect back into the same direction. Yes or no? Here also same thing. So if the light ray is passing along the normal line, it retraces its original path, reflect back into the same direction. Here also I am taking object A, B. Okay. So if the light ray is coming from the object, if it is passing like this, after reflection it retraces its original path. Okay. Another light ray is incidenting at here, so it will be reflected back. Okay. So next one you can observe here. So this is the one more object and image. One more I am taking like this. So this will be reflected back. Okay. Yes. Now you can check here. So this is the object. So if you are extending these light rays, these extended light rays are meeting here. The image will form here. This is the A dash and B dash. Okay. Object is real. Image is virtual. As I mentioned, as I mentioned, okay, as I mentioned, object is real, image is virtual. Object is real, image is virtual. Okay. So in case object is virtual, image is real. Yes. Okay. Point number 1. Coming to point number 2, object is real, image is virtual. Object is virtual, image is real. Coming to point number 2, object distance is equal to image distance. Object distance is equal to image distance. And the height of the object is equal to height of the image. We can say size of the object is equal to size of the image. Yes. Once again, object distance is equal to image distance. And the height of the object is equal to height of the image. Right? Yes. And here in plane mirror, magnification is +1. What is magnification? Height of the image by height of the object. Height of the image by height of the object. The ratio of height of the image by height of the object is equal to magnification. Magnification is +1. Magnification is +1. Okay. And one more point. What is that? It also shows lateral inversion. It also shows lateral inversion. Lateral inversion. What is a lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. Lateral inversion. Once again, here object distance is equal to image distance. Point number 1. Height of the object is equal to height of the image. Or size of the object is equal to size of the image. Point number 2. And coming to point number 3, magnification is +1. Magnification is +1. That is nothing but height of the image by height of the object. And the last point is lateral inversion. Last point is lateral inversion. Just check once here. Okay. So object distance. What is object distance? The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Object distance is equal to image distance. Height of the object is equal to height of the image. And magnification is +1. And the last point is, fifth point, it also shows lateral inversion. Lateral inversion. Yes or no? Lateral inversion. These are the points. These are the points I am saying till now. Okay. Object is real, image is virtual. Object distance is equal to image distance. Height of the object is equal to height of the image. Magnification is +1. And also it shows lateral inversion. Yes. Clear. Right? These are the points. 1, 2, 3, 4, 5. Let's start. Next one. Next one, the mirror which is in the form of curved surface. The mirror which is in the form of curved surface is called spherical mirror. The mirror which is in the form of curved surface is called spherical mirror. There are two types of spherical mirrors. One is concave mirror, another one is convex mirror. Once again, the mirror which is in the form of curved surface is called spherical mirror. There are two types of spherical mirrors: concave mirror, convex mirror. Concave mirror, the mirror whose reflection takes place inward. The mirror whose reflection takes place inward is called concave mirror. The mirror whose reflection takes place outward is called convex mirror. So concave mirror is in converging nature. Concave mirror is converging in nature. Whereas convex mirror is diverging in nature. Sir, how you are saying concave mirror is converging in nature, convex mirror is diverging in nature? How you are saying all those points? Now, just look at the board. Now you can see here, this is spherical mirror, the mirror which is in the form of curved surface, based on coating. So if it is coating outward, that is concave mirror, okay. So and reflection takes place inward, and in this case, so reflection will be outward, curved silver coating, yes, silver coating will be inward. Okay, so here you can see, yes, silver coating. So curved surface, reflecting surface will be inward, silver coating will be outward. Okay, and coming to here, in this case, reflecting surface will be outward here in this case, and silver coating will be inward. This is concave mirror, this one is convex mirror. What is this one? Concave mirror. What is this one? Convex mirror. So concave mirror is in converging nature. How? When light rays are incidenting on it like this, after reflection those light rays are meeting at one point here. So after reflection those light rays are meeting at one point here. So in this case, after reflection these light rays are moving away from the principal axis. Away from the principal axis. Understood? Away from the principal axis. Is it clear? Is it clear? Yes. I hope it is very clear. I hope it is very clear. Right? Now we will discuss about terms related to spherical mirror. Terms related to spherical mirror. Okay? Terms related to spherical mirror. Okay, now you can see here. So I'm taking like this. This is a part of this sphere. This is a part of this sphere. This is the center of the curvature. Center of the curvature in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. After reflection, all light rays will meet at one point on the principal axis called focus. The distance between focus to pole is called focal length. Focal length. Okay? Focal length. Understood? Just check once. So here, this is the pole. So I am considering like this. What is this mirror? What is mirror? Concave mirror. What is this type of mirror? Concave mirror. Okay. So the line joining of center curvature pole is called principal axis. The line joining of center curvature and pole is called principal axis. After reflection, all light rays are meeting at one point on the principal axis is called principal focus. So here I am taking this one and this one. After reflection, those light rays are meeting at one point on the principal axis called focus. Generally, it is principal focus. Simply, we can say focus. Simply, we can say focus. Okay. And the distance between focus to pole. The distance between focus to pole is called focal length. So, we'll denote with a small letter f. The small letter f. And the distance between center of curvature to pole is called radius of curvature. Radius of curvature. Understood? Understood? I hope it is very clear. Is it clear or not? Yes or no? The center of the imaginary sphere in which mirror is a part is called. The center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. Midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called principal axis. The distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. Radius of curvature. Yes or no? So, after reflection, all light rays are meeting at one point on the principal axis. Is called principal focus. Simply we can say focus. Simply we can say focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And width of the mirror is called aperture. Width of the mirror is called aperture. Yes, aperture. Right? So these are the points. These are the points you can observe here. The center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. So after reflection, all light rays are meeting at one point on the principal axis called principal focus. Simply we can say focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And width of the mirror is called, or diameter of the reflecting surface is called aperture. Diameter of the reflecting surface is called aperture. The distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. So these are the points. So I am writing on the board. Just check once. One is center of curvature. Second one is radius of curvature. Third one is pole. Fourth one is focus. Fifth one is focal length. And sixth one is aperture. And seventh one is principal axis. Seventh one is principal axis. Yes or no? Principal axis. These are the terms related to spherical mirror. Very, 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 very important. Very, very important. The distance between focus to pole is called focal length. And width, and the distance between center of curvature to pole is called radius of curvature. And width of the reflecting surface is called aperture. Line joining of center curvature pole is called principal axis. These are the terms related to spherical mirror. These are the terms related to spherical mirror. Now we will discuss about ray rules. Ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. After that, image formations by concave mirror and convex mirror. Image formations by concave mirror and convex mirror. After that, we will discuss about sign conventions. After that, we'll discuss about mirror formula. After that, we'll discuss about magnification. After that, we'll discuss about refraction. Refraction. Yes, refraction. Right? Chalo. Na 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 na. So do like, share and subscribe my channel. If you like the content, if you like the channel, if you like my explanation, so go for super chat, super thanks and be a member to get and to solve your doubts in advance. Okay, so go for it. And if you like the content, so inform your friends, ask your friends to join to the class. Okay, yes. So this is our Siva sir from Student Brand. Next one, we are going to discuss about rules of concave mirror and convex mirror. So concave mirror, pole, focus, center of curvature. Light ray is coming from infinity. Light ray is coming from infinity. Light ray is coming from infinity. After refraction, after here reflection or refraction? What do you mean by reflection? What do you mean by refraction? The bouncing back of the light from the reflecting surface is called reflection of light. So light rays bending, the path of the light changes at the interference of the two media is called refraction. Now in this case, only reflection is going on. Only reflection, right? Yes. So when light ray is coming from infinity, after reflection it passes through focus. Okay. So light ray is coming from infinity, after reflection passes through focus. That is the first one. Coming to the second one, light ray is passing through focus. So pole, focus, center of curvature. Light ray is passing through focus. After reflection moves towards infinity. Third one, light ray is passing. Turn, 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 turn. Na ne na ne na na ne na ne na na na. Na ne na ne na na ne na na. La le la la le. La le le da na. Na ne na ne. Na na ne. Na 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 na. Na ne na ne na na. So this is a concave mirror. Concave mirror. Yes or no? Now convex mirror will discuss. Convex mirror. Convex mirror. What is that? Convex mirror. Right? So here we can take pole, focus, center of curvature. Light ray is coming from infinity. After reflection passes through focus. So that is the first one. Coming to the second one. Light ray is passing through focus. After reflection moves towards infinity. Yes or no? So here I am taking like this. So pole, focus, center of curvature. Light ray is passing like this. After that, moves towards infinity. And coming to third one. What is third one? Light ray is passing through center of curvature. It retraces its original path. Yes. So you can observe here. Pole, focus, center of curvature. Light ray is passing through center of curvature like this. It retraces its original path. It retraces its original path. Yes. The next one is light ray is incidenting at the pole, it reflects back. Light ray is incidenting at the pole, it reflects back. Okay, like a reflection phenomena. The bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface. The same, like here also, when light ray incident at the pole, it reflects back. When light ray is incidenting at the pole, after reflection, it reflects back into the same medium. Yes. Okay. You can see here, fourth one. So pole, focus, center of curvature. After reflection, it moves in the same direction. Hello, hi. Welcome to the class. Right? Next. So now we will discuss about terms related to spherical mirror. Terms related to spherical mirror. Okay. So do like, share and subscribe to Student the Brand. Do like, share and subscribe to Student the Brand. If you like the content, if you like my explanation, share to your friends, ask your friends to join to the class, inform in your groups. So your near ones, inform to your college mates, school mates, those who are studying grade 10, 11, 12, and those who are preparing for NEET and JEE also. These topics are very helpful. Okay. I hope it is very clear. Yes. Okay. So thank you so much for joining and attending and listening. Do like, share and follow my channel and inform to your friends. And if you want, so if you like the channel, if you want to support the channel, you can go for super chat, super thanks, and go for membership to this channel. Okay. Yes. Now we'll discuss about image formations. Image formations. Let's start image formations. Okay, point number one. So pole, focus, center of curvature. Object is placed at infinity. Image is forming at focus. Object is placed at infinity. Image is formed at focus. What is the nature of the image? Real and inverted and highly diminished. Real and inverted and highly diminished. You can check here. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Yes or no? How many light rays are required to form the image of the object? Minimum 2 light rays. How many light rays? Minimum 2 light rays are required to form the image of the object. Object is at infinity. Okay. So where image will form? At focus. Okay. What is the nature of the image? Real, inverted, real, inverted, and real, inverted, and highly diminished. Because image is formed at focus. Image is formed at focus. Yes. Object is at infinity, where image will form at focus only, no? What is the nature of the image? Real, inverted, and highly diminished. Why it is highly diminished? Because it is a point size image. Is formed at focus. Huh? Yes. Now you can see object is at object is object is at infinity, where image is formed at focus. What is the nature of the image? Real and inverted and highly diminished. Point size. Point size image is formed. Second one, where object is placed beyond center of curvature, where image will form between C and F. What is the nature of the image? Real, inverted, and diminished. Object is placed at beyond center of curvature. Image is formed between C and F. What is the nature of the image? Real and inverted and diminished. Real, inverted, and diminished. Yes or no? Very, very important topic. Very, very important point. Let's discuss. Huh? So, what is this one? What is this one? What is this type of mirror? Concave mirror. What is this type of mirror? Concave mirror. Yes or no? Okay. Yes or no? Concave mirror. And second one, pole, focus, center of curvature. Pole, focus, and center of curvature. Object is placed beyond center of curvature. Object is placed beyond center of curvature. I am placing object here. This is the object. This is the object. Where image will form? Where image is forming? Between C and F. Between C and F. Okay. Between C and F. How many light rays are required to form the image of the object? Minimum 2. I am taking like this. Yes. Okay. Yes or no? Where is image is formed? Between C and F. What is the nature of the image? Real, inverted, and diminished. Real, inverted, and diminished. Yes. 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 Okay, so image will form here. Object is placed beyond C. Image will form between C and F. Nature of the image is. Okay. Real, inverted, and diminished. Diminished image. Yes or no? Diminished. Wow, amazing. Next one. object is placed, okay, object is placed, where is object is placed? At center of curvature, where image will form? At center of curvature only. What is the nature of the image? What is the nature of the image? Real, inverted and same size. Real, inverted and same size. Okay. So, I'm drawing here. Check once. So, third one. So, I'm taking like this. Va, 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 va. Na, 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 na. No. Where is object placed? At center curvature. Where image is forming at center curvature only. What is the nature of the image? Real, inverted and same size. So I'm taking here. This is one light ray. One light ray I'm taking like this. After that passes through focus. Oh my god. 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 Where the object is placed? Where the object is placed? Where is object is placed at center of curvature? Where image is formed at center of curvature? What is the nature of the image? Real and inverted and same size. Same size. And coming to the fourth one. Object is placed between C and F. Object is placed between C and F. Image will form beyond center of curvature. Object is placed between C and F. Image will form beyond center of curvature. Nature of the image is real, inverted and enlarged. Real, inverted and enlarged. Yes. 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 So let's start. Here I am taking like this. So pole, focus, center of curvature. Object is placed between C and F. Where image will form beyond center of curvature? Yes or no? Beyond center of curvature. One light I am taking like this. It passes through focus. Another light ray is incident at the pole. The light rays will meet here. The image will form beyond center of curvature here. The image will form here. Okay. So now you can see object is placed between C and F. So image will form beyond C. Beyond C. Nature of the image is. Nature of the image is. Okay. Nature of the image is. So real, inverted and enlarged. Real, inverted and enlarged. So coming to the fifth one. Object is placed at F. Where image will form? Image will form at infinity. Object is placed at F. Image will form at infinity. Nature of the image is real, inverted and highly enlarged. Real, inverted and highly enlarged. Right? Yes. Just check once here. So fifth one. So concave mirror, pole, focus and center of curvature. Pole, focus and center of curvature. Object is placed at F. One light I am taking like this. It passes through focus. Another light is incident at the pole, it reflects back. Object at F, image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Coming to the sixth one, image formation is very important. Sixth one, image formation is very important. 3 mark question, compulsory question, damn sure question. It will come for exam. That much important. That type of question it is. Okay. So let's discuss. Right? Yes. Sixth one. So I am taking here. So pole, focus, central curvature. Object is placed between F and P. Object is placed between F and P. One light ray after reflection passes through focus. Another light ray is incident at the pole, it reflects back. So if you are extending these light rays, those light rays will meet behind the mirror. Those light rays will meet behind the mirror. What is the nature of the image? So you can observe here. These light rays will meet here behind the mirror. Object is placed between F and P. Image will form behind the mirror. Nature of the image is virtual, erect and enlarged. Virtual, erect and enlarged. Okay. So object is placed between F and P. Image will form behind the mirror. Nature of the image is virtual, erect and enlarged. So very important. Very important. 3 marks question. 3 marks question. Very important. Applications are very important. Okay. So applications of concave mirror, applications of convex mirror. Convex mirror is also used as rear view mirror, side view mirror. So concave mirror will be used as torchlight, headlights. Okay, so to reflect the lighters. So in concave mirror will be used as a torchlights, headlights of the vehicles. Okay, so if you place the convex mirror in front of the any object, so we can able to see full view of the object. Full view of the object, right? Let's start. Now I will discuss about image formation by convex mirror. Image formation by convex mirror. Let's start, right? Yes. Image formations by convex mirror. So image formations by convex mirror. Convex In convex mirror, only two cases are there. Case number one. So this is the convex mirror. Optic center. So pole, focus, center of curvature. So light rays are coming from infinity after reflection. Those light rays are moving away from it. Those light rays are moving away from it. So if you are extended those light rays, object is at infinity, image is forming at focus, nature of the image is virtual and erect, size of the image is diminished, highly diminished. We can say highly diminished because point size image is forming at center of curvature, highly diminished, highly diminished. Diminished. Okay, so point number one. Coming to the next one. So pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed between P and infinity. Object is placed between P and infinity. So one light ray passes through focus. Another light ray is incident at the pole. It reflects back. Okay, if you are extending these light rays, the image will form between P and F. Okay, so now you can see. Okay, object is placed between P and infinity. Nature of the image is virtual and erect. Size of the image is diminished. Okay, image is found between P and F. Okay, so nature of the image is virtual and erect. Size of the image is diminished. Okay, size of the image is diminished. I hope it is very clear. Right? Yes. Okay, so do like, share and subscribe to Student D Brand. Please support my channel. Please support me. So if you like the content, if you like the channel, if you like my explanation, please share to everyone. So do like, share and subscribe. So then you'll get notifications regarding the live classes. And if you want to go for it, so go for a super chat, super thanks, and be a member to the channel. So thank you so much for supporting and encouraging. Okay, so thank you so much to you all. Right? Yes. Next. Next we are going to the next one, that is sign conventions. Okay, sign conventions. So you can see. So you can observe. So this is the concave mirror. So center of curvature like this I'm taking. Okay, so you can see here. Right. So all measurements will be taken from the. Okay, all measurements will be taken from the pole. In the direction of incident rays, all are positive. Those are object distance, image distance, all are positive. Opposite incident rays, all are negative. Above the principal axis, all are positive. And below the principal axis, all are negative. Okay. So now I'll sing a song. New Cartesian, New Cartesian, sign convention, New Cartesian, sign convention, all distance measured from the pole. Distance are positive along the incident rays. Distance are negative opposite to incident rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian, New Cartesian, sign convention, New Cartesian, sign convention, all distance measure from the pole. Distance positive along the incident rays. Distance negative opposite to incident rays. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian, New Cartesian, sign convention, New Cartesian, sign convention. So likewise, like that. So we can learn sign conventions. It's like a coordinate system. You know that positive x-axis, negative x-axis, positive y-axis, negative y-axis. Okay, so likewise coordinate system, how you are taking here also same thing, negative y-axis. Understood? So all measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. These are the sign conventions. These are the sign conventions. Right? Yes. Now, mirror formula. Mirror formula and magnification we will discuss. Nani na nani, nani na na. Yes. Now. Thank you so much. So some of you are supporting very well. So I'm happy for it. Okay. So actually, right from 2000, you can check once. So right from 2020 onwards, I'm continuously teaching. Okay, so it is 26. So you can go and check my channel. So from which year onwards I am posting the videos. Physics, completely, purely related to physics. There are many videos. You can check now. So how many videos I posted. nearly 5.5k videos. So there is a lot of hard work behind of it. So this is the output you are saying, but background there is so much hard work, right? So normally we see the movie, okay, front part only on the screen. So background there is a lot of hard work. There are so many people are doing already done, okay. So after many people hard work, the result will be you are seeing on the screen. So here also same thing. So behind of me there are many lot of videos you can see. There are many hurdles, like so many videos related to physics, that too experimental videos, like different costumes, different idea with different ideas. So completely it's related to physics only. So it's not beyond the physics subject. It's completely purely dedicated to physics. You can check the channel. So there are number of videos. So videos count also it will be there. It will display, right? Okay. So I'm completely dedicating to online, that to live classes. There are, after posting many videos, number of videos I posted, like different experimental videos, completely related to physics. Grade 10, grade 11, grade 12, okay, for JE students, for NEET students, and right from 6th to 10th, those are studying from 6th to 10th, for them also it will be helpful. That type of videos also I posted in the channel. Number of videos completely related to physics, okay. So there is a lot of hard work, guys. There are so many days I did so much hard work for posting the type of videos, okay. So I am doing my work. Please support. I need support from you all. So I need your support. I need your encouragement. So I need your positive support, okay. Then I can continue my work until, so we don't know until how much it will take, how much distance it will go. So until that much distance, that much far I will go to take the channel to reach maximum heights, okay. Definitely I will do my level best to teach in a creative way, innovative way, better way, okay, to the students. So if you like the channel, so I need your support. I need your support, okay. I need your support. So please do like, share, and subscribe. That is what I want. So without your support, so if I do lot of hard work, without your support, I am zero. Definitely, I'm a zero hard work. You know. So there are many videos, number of videos, like count, like see. So you are saying that count, but behind of it, countless experimental videos I did. Experimental videos I did. So I want your support. I want only your support. Without your support, I can't able to move forward. Okay, I can't able to move forward. I am teaching physics subject. I'm not teaching anything. I'm teaching only physics subject. That too helpful to the students only. If you want, just you can go and check the videos are there in the YouTube channel. Completely related to physics subject only. Many videos, number of videos are there. Okay, so it will be helpful for the students. So try to support to me. So I need your support with a strong support, unbreakable, unmatchable. So please subscribe, please do like, share, and subscribe. So with that support, definitely I can reach to the maximum number of students. And one more thing, so do share the channel to remaining ones, and those who are there in your college, those who are there in a school, okay, those who are there in near to you. So share, just drop a word, okay, drop a word, drop a word to your parents. So sorry, to your friends in your college, in your school. Yes, of course, you can inform your parents also regarding the channel. Okay, that will be great help to me. Okay, they will also get to know. They will also, they can understand my hard work. Okay, they can understand my hard work. Okay, so automatically they will also inform. They will also share. They will also inform to the other people. Okay, right? So thank you so much for joining and supporting and encouraging. Thank you so much to you all. So I need your support. So with a strong motivation is required to me from you all. Okay. So by your actions, by sharing to all, by liking, subscribing, and sharing to remaining students. Thank you so much. Okay, done. So apart that, we'll go to the next one. We'll go to the next one. Sometimes it happens. Sometimes it happens with your energy, with your positive feedback. Definitely, I will rebounds. Okay, so next one, coming to the formula, 1 by f equal to 1 by v plus 1 by u, mirror formula, and magnification equal to m equal to, so height of the image by height of the object, that is nothing but minus v by u. Minus v by u, that is a magnification. Okay, so thank you so much for joining and attending, listening, and still light refraction topic is left, so that I will discuss in the next class. Okay, so continuously live class will be going on, every day live classes will be there. Okay, so continuously live classes will go on. So okay, so please do like, share, and subscribe, and inform to everyone, inform to your all your friends, inform to your inform to your friends those who are there in the college, inform to your friends those who are there in our school. If you are studying in 10th class, you can inform to your friends. Those who are studying in 11th and 12th, inform to your friends. Okay, so please share a word to your friends. Thank you, thank you, thank you so much.